Good Sunday afternoon, everyone. Welcome to GardenStateWeather.com Premium Superior Forecasting for Service Industries. This is our first premium video forecast discussion on our new platform that we have developed here with our team of forecasters here at GardenStateWeather.com. This is for the service industries, and right now it's free. The consulting video that you're seeing now and the updates on things such as the stratosphere and our forecasting techniques are free right now for you to preview here on social media and through this link here on the website. And what we're trying to do here right now, we're just accepting donations through PayPal and general credit cards for the cost and effectiveness of what we do here as forecasters for you, the general public. And specifically, this website is going to be designed for contractors and energy consultants or energy industries that need updated live forecasting for winter storm totals and also for, everything that has to do with energy, heating degree days, heating cooling days, such as these things, and a plethora of other forecasting techniques and things that we do here at Garden State Weather that make a difference in your general forecast. Now, right now the service is free, and it's going to be free through the end of this month of November 2019. And then we're going to go from the donation box that you see on the website on the right-hand side corner here. We're going to go into basically a shopping cart. So you're going to transition into a shopping cart. And if you like the service that we provide and you want to be able to view the detailed information, get live forecasting, telephone calls, all that information for you, the client, that we can provide for you, then obviously we'll translate that information going forward. But for today, I just wanted to start out the video forecast discussion talking about some of the things that we're looking at here at the Weather Center in terms of the stratosphere and other forecasting tools that we're looking at to indicate what the weather conditions are going to be going forward for the rest of this month and into December. Okay, first of all, I wanted to go over a few things here. This is the what it looks like here on our premium site at the moment under the design page called Premium Consulting, which is now publicly available for the end of this month. And on this particular page, you're going to see video forecast discussions. And you're also going to see, like the one we're producing right now for you now, and also updates on things that we normally do in blogs on our other websites that are not going to be available to the general public after the end of this month. So this is a premium preview of some of the things that we're looking at. And right now, for example, for today, say November 10th, 2019, we talk about the stratosphere, its implications downstream into December. And then we're, today we're going to forecast and also talk about And today, again, it's a little broken up, but we're going to talk about the implications of what we're seeing in the data and how that translates to a change. Now, things that happen in the stratosphere generally take anywhere from 10 to 15 days to work down to the troposphere. So the influences of what I'm going to forecast and going through right now, these changes in the stratosphere are going to take about 10 to 15 day lag in the actual weather forecast that you're actually viewing from the GFS or the European Model Guidance or any of that. We'll get into that right now. Okay, first of all, I want to talk about the layers of the atmosphere that make such a difference in our forecasting here at the surface. Now, we live in the troposphere here, which extends up to about 10 miles in space, and this is where most of the weather that you see happens. The layer above this, we have an ozone layer here, and then the layer above this is the stratosphere, which extends up to about 30 miles into space. And this layer of the atmosphere gets either increased or decreased by other stratosphere, other things that are going on both in the mesosphere and in the thermosphere, and then finally into the exosphere and out of space, which we do not talk about too much. So basically, weather balloons get up into the stratosphere. In the troposphere where we live, that's where weather is happening. And we can see this by the stratosphere as it cools and warms. There are warm pools and cool pools in the stratosphere that work from the equator northward, from the equator northward actually, and that increases either the warming of the stratosphere or the cooling of the stratosphere, which we call stratospheric warming. And one thing to note here is that if the stratosphere is increasing in heights and increasing in temperatures, that compresses down on the troposphere, and that compresses down on the 500 millibar pattern and the jet stream structure throughout the United States and throughout the world actually as well. We can take a look at the diagram from above here. Normally the stratosphere, just before it gets to the top of the tropopause here, is generally warmer at the top and cooler underneath. And the troposphere is warmer as you go from the surface of the ground all the way up to 10 kilometers, or about 6.2 miles in space. And then we have the stratosphere, which actually is warm at the top at about 31 miles up in space, down to the lower layers of near the tropopause or the troposphere. So it is in these layers of the atmosphere where, we find high latitude blocking, warming and cooling in this layer here. And when the stratosphere actually warms or cools, it either contracts or expands the troposphere in where we live, where the weather occurs. So, for example, if we're looking at stratospheric warming, that stratospheric warming then extends down lower in the stratosphere, and that means that it compresses the warm air in the stratosphere, then compresses down the layers of the troposphere where we live, where weather occurs. 99% of the time, all weather concerns here are in the troposphere because there's mixing and vertical motion in this layer, the lower layer of the atmosphere, the troposphere, and where, we get to. Now, flights begin at the tropopause and into the lower layers of the stratosphere because there's little vertical motion going on here. And as a result of that, there's, flights that go up to, 10 kilometers or up to these flight levels here just before we reach the ozone layer in the lower layers or mid layers of the stratosphere. So basically, when we have stratospheric warming, the normal cooling that occurs in the lower layers of the stratosphere begins to increase. The warming increases, and this presses down on the troposphere. So if we have all of this motion that's increasing, or heights increasing, and temperatures increasing in the stratosphere, that actually contracts the troposphere. And when we contract the troposphere, that's when weather really starts getting undulating jet stream structures throughout the world. So right now we're going to take a look at the latest guidance here from the European model guidance, which is forecasting at 10 millibars, which is the upper reaches here of the stratosphere. And remember, all of this is opposite down on the ground. So if you're up in the stratosphere and you find below normal heights here, where our polar vortex is located, into southeastern central Canada here, and warmer than normal heights here, it's the reverse at the surface. So if we have all of this area here from the North Pole down through the upper Midwest or whatever, and also portions of the Dakotas here and Minnesota, and this in the upper layers of the stratosphere is pointing to warmer than normal heights, high pressure over these areas with warmer than normal temperatures at the surface. here on the East Coast, we have blocking over Europe and we have blocking over Scandinavia, and also here from Greenland or just off of Greenland and portions of Europe south into the south central United States. So this is supporting below normal heights at the surface, and that's why we're seeing all of this Arctic air that's coming in. So it's the opposite from the stratosphere. So if the stratosphere is decreasing heights over this area, at the tropospheric level, it's increasing heights. So you have warmer temperatures. Also, the same thing is true with high latitude blocking showing up here and here. And this is actually a trough axis with much cooler air in this region of the country as you get down to the surface. Now, if we looked at 500 millibars at the same level here, not 500 millibars, but 50 millibars actually, you can see the stratospheric warming on all sides to the north of the pole into the other side of the pole here. So now we're entering into the South Pole here, and you can see all of this cooling and the elongation of the polar vortex here. So what this is showing right now is that, you know, there's a lot of warming going on in this area and a lot of cooling going on in areas where the blocking is showing up at the surface. Now, this is where the blocking is aloft. So if the blocking is this way aloft, then at the surface, it's actually the opposite. And again, using the European model guidance here from last night for this morning here, on the 10 millibar temperatures, the upper reaches of the stratosphere, we're finding a lot of cooling over the Aleutian Islands down through the Pacific Northwest, and this would indicate high pressure and above normal temperatures through this area here. But we're also seeing the effects with the temperatures above normal in the stratosphere at 10 millibars over Europe and portions of Greenland and over the other side of the pole here, but specifically over Northern America from east of the Rocky Mountains. And this signature tells me, especially here south of Greenland and off of the Nova Scotia here into the Atlantic here, that at the surface we're seeing a trough-like signature, which is definitely indicating polar air and Arctic air in place. Now, with the European model guidance at 10 millibars, the top of the stratosphere, as we head into the week prior to Thanksgiving in the stratosphere, remember, it's going to take 10 to 15 days for these effects to get down into the troposphere to formulate the weather pattern and the undulations and cold fronts and warm fronts and jet stream structure and short waves in the flow. But what we're seeing that the model guidance here is trying to show is that we have a stratospheric warming going on towards the Aleutian Islands and just trying to disrupt the polar vortex here and trying to push it onto the other side of the pole. And this is last night's guidance. So at 10 millibars, what this is actually showing you is that a change is on the way. If we find higher than normal heights here, that translates to lower than normal heights over the west coast and over the Aleutian Islands. And also the same thing can be true for the eastern United States, where, you know, we're finding warmer than normal heights being pushed upon by this stratospheric warming event. And that would mean, and that would translate into a ridge, actually, a ridge across the eastern United States with a warming trend. And we can see this in the height profiles and also in the polar vortex being stretched and pushed from Greenland and to the other side of the pole. If we took a look at 10 millibars for day 10, here's another example. Warmer than normal temperatures at 10 millibars, the upper reaches of the stratosphere, is actually allowing for a cooling trend here across these areas of the world and also into the western United States. And notice that you're finding the same thing to be still true over the eastern United States and into Atlantic Canada as well, and portions of the Atlantic here, where there's a lag time here in temperatures at this level of the atmosphere would support the opposite, would support the fact that we're going to have warmer temperatures starting to build up, or cooler, actually still cooler temperatures still in this area, and a lot of precipitation in this area of the country as well. The one thing that stands out here on the European model guidance out to day 10, which is about 240 hours, that would be November 20th, again, the week before, during the week of prior to Thanksgiving here, is that we have below normal temperature profiles at 50 millibars, actually the middle of the stratosphere here, and that supports above normal heights and above normal temperatures over Greenland, and that indicates a blocking mechanism. We have, we're going to have, some kind of a negative NAO going on, North Atlantic Ice Oscillation. Meanwhile, as this translation is continuing, we have above normal temperatures in the stratosphere at, the mid-levels here over the Gulf of Alaska and all the way through the central and eastern United States into the Atlantic. And this indicates where the pattern is trying to change here, because this indicates to me that it would be the opposite as we go forward down to the surface, where below normal temperatures are going to start to translate from all of this warming here over the Gulf of Alaska and the Aleutian Islands, and also over the East Coast and central and eastern United States out into the Atlantic. But changes are on the way. If we look at the GFS, the operational GFS right now from this morning's 12Z run in the stratosphere, in the upper reaches, the top layer of the stratosphere, we can find where the stratospheric warming is not that evident yet. But what's happening is here is our polar vortex, and it's elongated. So we have below normal heights here across southeastern central Canada, and that means higher pressure at the surface over these regions of the world. And where we find the warming here out into the Atlantic and back down through the United States, especially the Appalachian Mountains all the way down through the southeastern United States, more prominent here in the mid-Atlantic region and southeast. That means that we're having cooler than normal temperatures with a trough-like configuration at the surface. Now, the latest operational GFS stratospheric forecast at 10 millibars, the upper reaches of the stratosphere again, shows this big, large warming event occurring here over the Aleutian Islands, down through Canada, Siberia, and all the way into southeastern Canada, and even including Hudson's Bay. So this shows me at the surface that the polar vortex is being stretched and elongated, but it's moving into the other side of the pole temporarily. This is a forecast that the model guidance is showing, and what this shows me is that all of these warmer than normal heights in the upper layers of the stratosphere mean that we have higher pressure, lower pressure actually at the surface evolving over these locations, and higher pressure over the eastern United States. And this would lead into the week of Thanksgiving here. And it's probably an indication where this configuration may continue until this stratospheric warming event reaches its peak. It's the first of many this season because our EPO is so negative. We'll get into the teleconnections in just a moment, but this probably means that the East Coast is going to actually warm up and the West Coast is going to cool down, and we still have a very active subtropical jet stream configuration, not shown here in the stratosphere, but we'll show that in operational runs of the model guidance going forward. And remember, this is a lag time. What happens in the stratosphere takes about 10 to 15 days to work down to the troposphere where we live. So we're going to find areas that, it's going to take a while for the pattern change to show up, but the reversal of what I'm seeing here is actually showing up. Now, If we looked at the guidance here for 16 days out on the new NCEP operational GFS here, here's where everything is maximized here in the mid-levels of the stratosphere. A large amount of warming now has reached towards and getting towards the pole here, and it's elongating the polar vortex, and it's trying to split the polar vortex into two. Okay, one on the other side of the world here in South America, heading towards South America, and the other here over the Atlantic, going into Europe. So all of this warming here that you're seeing at day 16, which would be just a couple of days before Thanksgiving, means that lower than normal heights are going to be seen in this location, and warmer than normal heights are going to be seen where, at the surface, where everything is just in white here. So we are in for a transition, but again, this is the first of many stratospheric warming events going forward this winter. But location is important and location is key, and that is the reason why winter could be delayed. And you could see a definite warm-up here in this pattern across the eastern United States, given these factors here through the early portion of December as well, because remember, it takes 10 to 15 days for the lag time here, and that's where we're going to get into the forecast discussion of what the model guidance is showing. Okay, down to sensible weather here. This is the 500 millibar charts from the morning run of the GFS. And basically, below normal heights are seen over southeastern Canada, obviously Hudson Bay, the northeastern United States. Here comes a polar cold front, an Arctic cold front actually, as we head into Tuesday morning with the area of low pressure in the height fields here over southeastern Canada. That swings through. Now, this is the area that's, going to, appreciate some, rain showers and snow showers, but accumulations, as we discussed on our blog site this morning, are going to be less than, an inch or two. Higher elevations, northwest Jersey and the Poconos, the Hudson River Valley area. Into New England, that's where the greatest threat for accumulating snow has been and will continue to be. Now, the pattern evolution is very interesting because here, by the time we get to next Wednesday, again, the cold pool of air, the lower than normal heights here at 500 millibars, about, 10,000 feet, 18,000 feet up in space here, shows a basic trough access across the eastern United States. It minors out a little bit as you head south through the southern mid-Atlantic and also into the southeast states. But they're still below normal heights here, and you can see this vestiges over Mexico, which is, going to provide additional rain moving in this direction across even into Florida as we move forward. But in the wintertime, what you would like to see for snowstorms is a trough access over Montana. Now, the height ridges are building here, but they're and low pressures definitely. This is a negative EPO showing up again across the Aleutian Islands and further to the west. And there's a lot of high latitude blocking, which is trying to get its act together here. This is again on Thursday of this week coming up. So we know that the cold air and the frontal passage and trough axis is going to be in place. Now, here comes the next surge of cold air, and then a relaxation period where, back up here, here's the ridge access, it weakens, here's additional energy coming in from the Pacific, and again, we have a ridge access here over the southwest, United States and Pacific actually as well. We've got cutoff lows trying to develop here over Mexico, and another area of below normal heights here exiting, and new heights trying to reestablish themselves over Canada. So this is going to be an ongoing problem as we head into the month ahead. Actually, through the end of this month, we're going to find multiple areas in the Pacific and also the subtropical jet streams, which are going to try to merge But under this pattern here, they're not merging. So, and the trough and ridge axes are all over the place because of everything that's going on right now in the stratosphere. With the stratosphere warming and down to the troposphere, we find, the model guidance is going chaotic as we get down to 10 to 15 days, where we have cutoff lows, high pressure ridges, and storm systems in the polar and subtropical jet streams that will not merge correctly, and a trough axis also positively tilted and also in the wrong place. Lots of activity going on. So this is just a sample of what we're doing here at GardenStateWeather.com and the premium site GardenStateWeatherPremium.blogspot.com. Right now, we're formulating the ideas and we're getting our heads together to think about the exactitude of where we're going, and also at this point we're also trying to make a little money in donations to pay for all of the data services and everything that we use to provide all of this information to you, the general public. So we're going to continue to refine this through the days and weeks ahead. And this is just an example of some of the things that we're looking at and the impacts that they can provide for you as a service industry member and client here on Garden State Weather. So we're going to get back to you on that. This is a preview of some of the things we're looking at right now. I'm meteorologist Robert Smith. We'll get back to you throughout the day on Monday as well, and we'll continue to add new premium content free of charge until the end of the month of November, and that's when everything goes into a shopping cart. And if you want the kind of forecasting that we're doing, then you're gonna, pay a few bucks. That's it. For Garden State Weather, Premium.com. I'm meteorologist Robert Smith. Have a great Sunday.